Stars became visible in the deep black sky around the eclipse. Venus, Mars, Saturn. Planets that were invisible in the glare of the solar disk suddenly appeared, puncturing the darkness around the eclipsed sun like bright holes in the fabric of space. The crew wore eclipse glasses during the partial phases and removed them when totality was complete. And what they saw, unfiltered, with human eyes, in the silence of deep space, was something Reed Wiseman later told Mission Control that their brains simply could not process. But no matter how long we look at this, Wiseman said, his voice careful and deliberate, our brains are not processing this image in front of us. It is absolutely spectacular. And it was during this eclipse, during this near hour of totality, that the moon's surface turned dark. The sunlight that normally illuminates the near side was blocked. The far side was already in shadow. For a window of time that the mission had not specifically optimized for, but that the universe apparently decided to provide, the entire visible surface of the moon was in darkness. And against that darkness, 6 times the crew saw light. 6 separate meteoroid impact flashes. 6 times a space rock hit the moon at hypersonic velocity and burned bright enough to be seen by human eyes from more than 6,000 kilometers away. The lunar science lead, Kelsey Young, was watching from Mission Control when Wiseman reported the first one, then the second, then Hansen spotted another. She later said, with remarkable honesty, that she had not genuinely expected the crew to see any. She had trained them to look, had told them it was possible, had made sure they understood what to watch for. But she did not think the conditions would cooperate. The universe proved her wrong 6 times over. This is not a trivial scientific footnote. The rate at which the moon is being struck by meteoroids is a critical data point for every future mission, every lunar outpost, every design calculation for habitats and equipment on the surface. The planned Artemis base camp, the permanent outpost NASA intends to establish near the moon's south pole in the coming decade, has to be engineered to survive the bombardment. It will face continuously from above because there is no atmosphere to filter it. Radiation, temperature extremes, dust, seismic shaking, and impacts. These are the environmental hazards of living on the moon, and understanding the frequency and character of those impacts is not academic. It is existential for the people who will eventually live there. The crew of Artemis II just handed lunar engineers one of the most valuable direct observation data sets in the history of lunar science. But the science was only part of what this mission revealed. The other part was something harder to quantify and more important to understand. Christina Koch, after the mission was complete, after splashdown in the Pacific Ocean off San Diego on April 10th, spoke about what it meant to see the Earth from the other side of the moon. She spoke about looking back at the planet from a distance of over 400,000 kilometers, further than any human had ever been from home, and feeling something shift inside her. She said, when we have that perspective and we compare it to our home of Earth, it just reminds us how much we have in common. Everything we need, Earth provides, and that is somewhat of a miracle and one that you can't truly know until you've had the perspective of the other. That is not a press conference platitude. That is a statement from someone who has stood at the edge of the abyss and looked back. There is a documented psychological phenomenon called the overview effect, the cognitive shift that astronauts report when they see Earth from space, the sudden, overwhelming visceral understanding that borders are invisible from orbit, that humanity is a single species on a single fragile world, that every conflict and division and tribalism that consumes human energy on the surface is a small thing compared to the immensity of what surrounds it. But what the Artemis II crew experienced was something beyond even the overview effect. They did not just see Earth from orbit. They watched it disappear. They experienced the full weight of what isolation at 400,000 kilometers actually feels like. And then they came back, and that experience changed them in ways that are still being processed. Jeremy Hansen, the Canadian astronaut who became the first non-American in history to travel to the moon, described seeing the moon's 3-dimensionality as an experience that bent his mind. He was the first person from his country, from any country other than the United States, to ever see the far side of the moon with human eyes. He photographed it using a technique the crew developed to eliminate cabin reflections from the spacecraft windows, a camera shroud, essentially a small curtain with a hole for the lens, draped against the glass to prevent interior light from washing out the view outside. A simple, elegant solution that produced some of the sharpest direct photographs of the lunar far side ever captured by a human observer. The images he and his crewmates sent back are now being analyzed by geologists and planetary scientists who are finding details in the cratering patterns and surface geology that orbital satellites, despite years of mapping, had not revealed with the same clarity. One of those details involves the Reiner Gamma Formation, a bright, swirling pattern on the lunar surface associated with a localized magnetic anomaly that scientists still do not fully understand. The crew was tasked with observing and documenting this region during their flyby, and the images they captured of it are now feeding into models, trying to explain why the moon has these isolated patches of magnetic field when the moon as a whole lost its global magnetic field billions of years ago. It is a mystery that touches on the deep history of the solar system, on the moon's formation, on the collision event 4.5 billion years ago when a Mars-sized body struck the early Earth and threw into orbit the debris that eventually coalesced into the moon. Understanding the moon is, in ways that are not immediately obvious, understanding ourselves, understanding our origins, understanding how this particular arrangement of matter and energy and cosmic accident produced a planet capable of generating life and consciousness, and the kind of beings that build rockets to go back and look at the thing that made them. The crew also proposed names for 2 previously unnamed craters they observed during the flyby. One they called Integrity, after the spacecraft that carried them. The other they called Carol, after Commander Wiseman's late wife, who died of cancer in 2020. That second name, quiet and personal against the scale of the universe, is perhaps the most human detail of the entire mission. A man carried his grief 400,000 kilometers from Earth, looked down at a world that has been absorbing impacts for 4 billion years, and left his wife's name on it. The moon has been recording the scars of collisions since before the Earth had an ocean. Now it carries Carol. Here is what most people are not fully grasping about what the Artemis II mission actually accomplished. It broke the record for the farthest distance any human being has ever traveled from Earth, surpassing the mark set by the Apollo 13 crew in 1970 at 171 kilometers, reaching 406,171 kilometers from our planet. It sent 4 people further into deep space than any humans in more than half a century. It validated the Orion spacecraft's life support systems in conditions that Earth orbit cannot simulate. It produced the first direct-to-human observations of meteoroid impact events on the moon in real time. It captured the first total solar eclipse ever witnessed from behind the moon. It photographed regions of the far side that have never been seen directly by human eyes. It generated a trove of geological data that will shape every mission that follows. And it did all of this on a mission that, by the technical standards of what comes next, was a test flight, a proving run, a shakedown cruise. Artemis II was not the destination. Artemis II was the dress rehearsal. Artemis III is scheduled for 2027. It will not fly around the moon. It will land on it. 2 astronauts, including the first woman ever to set foot on the lunar surface, will descend to the moon's south polar region, a terrain of permanently shadowed craters that have not seen sunlight in billions of years and that almost certainly contain water ice that could be converted into drinking water, breathable oxygen, and rocket propellant. If that works, if the south pole of the moon becomes a resource base rather than just a destination, then the entire strategic calculus of human space exploration changes. The moon stops being a milestone and starts being a stepping stone. But even that framing underestimates what is really happening. Because the moon is not just a waypoint to Mars. The moon is a laboratory. It is 4 billion years of unaltered solar system history preserved in a surface that has never been geologically recycled, never been eroded by weather, never been disturbed by plate tectonics. Every crater is a timestamp. Every lava flow is a chapter in a history book that Earth's own geological activity has long since burned. The 6 impact flashes the Artemis II crew witnessed on April 6, 2026, were not random acts of cosmic violence. They were pages being added to that book in real time, and for the first time, human beings were there to read them as they were written. Mission Commander Reed Wiseman said something during the eclipse that has stayed in the minds of everyone who heard it. He said their brains were not processing what they were seeing, not because it was too fast or too faint or too technically complex, because it was too beautiful. Because the human visual system and the human cognitive architecture and the entire evolutionary history of a species that developed on the surface of one small planet was not built to process the corona of the sun backlit by the moon in deep space, while 6 rocks strike the surface below and the stars of the galaxy emerge around the darkness. It was too much, too real, too large. And here is the question that nobody is asking loudly enough. What did we miss? In those 40 minutes of total communication blackout, while Integrity was on the far side of the moon with no signal in or out, the crew saw things that they could only report after they emerged. Whatever happened in those 40 minutes, whatever they observed, whatever they experienced, in the absolute silence of a region of space shielded from every radio transmission human civilization has ever produced, the only record of it is what 4 human beings chose to say afterward. We have their photographs. We have their verbal reports. We have the data their instruments collected. But we have never, in all of recorded history, had a way to know what a human being sees and feels in 40 minutes of complete isolation on the far side of another world. The crew of Artemis II came back. They splashed down safely on April 10th, 2026. The Orion capsule Integrity hit the Pacific Ocean off the coast of San Diego and was recovered by the USS San Diego. 4 human beings who had been further from Earth than almost anyone in the history of our species walked back into a world that mostly went on with its morning routine. But something is different now. The data from Artemis II is feeding directly into the design of the Artemis III lander. The meteoroid impact data is reshaping the engineering calculations for lunar surface habitats. The geological images of the far side are being layered onto orbital satellite maps to produce the most detailed picture of the moon's hidden face that science has ever had. And somewhere in mission control at Johnson Space Center, the scientists who heard those impact reports and screamed with audible delight are building models that will tell future astronauts exactly how much danger they face from above when they are standing on the surface. What the Artemis II crew accidentally captured was not just stunning photography, it was evidence. Evidence that the moon is alive in a way that nothing we sent to orbit or land robotically could fully convey. Evidence that human presence, human eyes, human attention in the right place at the right moment produces scientific results that no camera algorithm or automated sensor has yet replicated. Evidence that the choice to send people, expensive and risky and complicated as it is not sentiment. It is strategy. The next crew will go further. They will go down. They will stand on a surface that has been waiting in the dark for 4 billion years, and they will leave footprints in regolith that has never been disturbed by anything with a heartbeat. And when they look up from that surface, they will not see Earth rising over a familiar horizon. They will see it hanging in a black sky, never setting, never moving, a fixed blue light in the permanent darkness of the South Pole. And if something goes wrong down there, if the mission encounters a problem that no simulation anticipated, there will be no 40-minute blackout. There will be a silence with no scheduled end. What was it, exactly, that 4 human beings saw in those 40 minutes behind the moon? What did those 6 flashes of light tell the moon's own surface about the solar system it lives in? What secrets are buried in the permanently shadowed craters that no sunlight has touched since the solar system was young? And if the moon's south pole contains the resources to sustain human life indefinitely, what does that actually mean for who owns it, who controls it, who gets to be there? Nobody is answering those questions yet. Not completely, not honestly. But 4 astronauts crossed 406,000 kilometers of empty space to start asking them with their own eyes, and what they came back with is more than photographs. It is a new set of questions that may take generations to answer, and the answers, when they finally come, are going to change everything. Nobody told you what they actually saw on the dark side of the moon. Not completely, not honestly. The official press release gave you photographs, it gave you sanitized quotes and carefully worded statements about scientific observations. But between the lines of every NASA briefing, between every rehearsed answer from every astronaut interview, something else was hiding. Something that the people who experienced it said their brains could not process. Something that made trained, decorated, psychologically vetted astronauts go completely silent. 4 human beings traveled further from Earth than any humans had in over 50 years, crossed into a region of space where radio signals cannot reach, where Earth itself disappears behind a dead world, and what they encountered on the dark side of the moon was not what anyone expected. And the deeper you look into what they actually reported, what they actually photographed, what they actually saw with their naked eyes in those 40 minutes of total silence, the more you realize that what we've been told is only the beginning of the story. This is not a mission recap. This is not a highlight reel. What you're about to hear is the account of 4 astronauts who went somewhere no human had been in half a century, and what they brought back from the darkness changes everything we thought we understood about our closest neighbor in space. It started on April 1st, 2026. Not a drill, not a simulation. The real thing. NASA's Space Launch System, one of the most powerful rockets ever constructed by human hands, erupted from Launch Complex 39B at Kennedy Space Center in Florida at 6:24 in the evening. Riding inside the Orion spacecraft they had named Integrity sat 4 people. Commander Reed Wiseman, pilot Victor Glover, and mission specialists Christina Koch and Jeremy Hansen of the Canadian Space Agency. 4 human beings sealed inside a capsule roughly the size of a large SUV, hurling themselves into the void on a rocket producing 8 million pounds of thrust. Think about that number for a moment. 8 million pounds of thrust, just to escape the gravitational grip of a planet that has held every human being in its arms since the first of our species drew breath. And they were leaving it behind. The journey to the moon takes time. It is not a short trip. It is not a commute. It is 4 days of floating through a void so vast and so indifferent that even the vocabulary we use to describe it falls short. In those first days aboard Integrity, the crew tested life support systems, fixed an onboard toilet malfunction, and watched Earth grow smaller through the spacecraft's windows. Reed Wiseman photographed the planet from one of Orion's 4 main windows after the translunar injection burn, and the image that came back to Earth showed something most of us will never fully comprehend. Our entire world, reduced to a crescent of blue and white light, impossibly small against the absolute black of space. Canadian astronaut Jeremy Hansen looked at that image and said it brought him to his knees. Not metaphorically, emotionally. The sheer scale of what they were doing, the distance they were covering, the silence that surrounded them, it stripped something away from the protective layer of normalcy that human beings carry everywhere they go. But here is where it starts to get strange. Because as the crew made their approach to the moon on April the 6th, 2026, something happened that no mission briefing had fully prepared them for. Christina Koch looked out her window at the moon growing larger in view, and she said something that should stop you cold. She said it looked wrong. Not wrong as in damaged or broken, but wrong in the way that only something deeply familiar can look wrong when you see it from an angle your mind has never processed. She said, and these are her exact words to NBC News from inside the capsule, "The darker parts just aren't quite in the right place." She was looking at the moon, the same moon every human being on Earth looks up at, the same moon that has governed tides and calendars and the dreams of poets for thousands of years, and her brain was rejecting what it was seeing, because she was approaching it from the wrong side. She was seeing the moon that no human eye is ever supposed to see from Earth. The far side, the hidden face, the side that has been locked away from human view since before our species existed. That disorientation, that moment where a trained NASA astronaut's mind misfired because it was confronting something genuinely outside the scope of human experience, that was just the prologue. The main event was still hours away, and it was going to be something else entirely. At 6:41 in the evening, Eastern Time, the Orion spacecraft slipped behind the moon. At that precise moment, Earth disappeared from the crew's view. Not gradually, not slowly. Earth simply ceased to exist as a visible object. One moment it was there, a crescent of light hanging at the edge of the lunar horizon in an image so beautiful it stopped Houston scientists mid-sentence, and then it was gone. The photograph the crew captured of this moment has since been called the Earth Set, a deliberate echo of the famous Earthrise photograph taken by Apollo 8 astronaut Bill Anders in 1968. But where Earthrise showed humanity, the Earth rising over the moon's horizon in a moment of almost religious hope, Earthset showed something quieter and more unsettling. Earth sinking, Earth vanishing. Earth ceasing to be visible to the four human beings who were now, at that moment, the most isolated people in the history of our species. And then the signal cut out. For 40 minutes, NASA's Deep Space Network, 3 enormous antenna complexes spread across California, Spain, and Australia, had no contact with the crew of Integrity. No telemetry, no voice, no data. The physics of the situation were absolute and inarguable. The moon's bulk sat between the spacecraft and every transmitter on Earth, and radio waves cannot pass through a planet. Flight Director Judd Freeling, sitting in mission control at Johnson Space Center in Houston, had one job during those 40 minutes: wait. He told reporters that physics would bring them back. He was right. But what happened in those 40 minutes of total silence was something that even the most optimistic mission planners had not put at the top of their prediction list. The crew was not just floating in silence. They were not simply waiting for the signal to return. They were working, observing, documenting. Because the far side of the moon, that perpetually hidden hemisphere, was directly below them, illuminated, close, and entirely available for human eyes to study for the first time in over 50 years. What they were flying over is genuinely alien territory. The far side of the moon is so fundamentally different from the near side that geologists still cannot fully explain why. The near side, the face we see from Earth, is partially covered by vast dark plains called Maria, ancient lakes of volcanic basalt that flooded from the moon's interior billions of years ago. The far side has almost none of that. It is ancient. It is scarred. It is a surface cratered upon cratered upon cratered, a geological record of 4 billion years of cosmic violence that was never resurfaced, never smoothed, never reset. It looks like something that has been under siege for an eternity, and in a very real sense, it has been. The crew photographed craters, not just any craters, but craters that unlock the mystery of how our solar system formed. The Oriental Basin, a multi-ringed impact structure 600 miles across that sits right at the transition zone between the near and far sides, came into view in a way that left the crew stunned. Jeremy Hansen later described the three-dimensionality of the moon as something that bent his mind. He meant that literally. The photographs you see of the moon from Earth are flat representations, two-dimensional projections, but the moon outside Integrity's window was a sphere, a real, physical, textured, three-dimensional object hanging in space, close enough that the crew could see individual craters and shadow patterns and geological features that had never been observed by human eyes from this proximity. Scientists back on Earth received the crew's images and began analyzing them immediately, looking for clues about ancient lava flows, tectonic fractures, the composition of the surface, the history of impacts. The data coming back from Integrity's cameras was, as one NASA official put it, a treasure chest. But the crater photographs were not what broke through to every scientist in the science evaluation room at Johnson Space Center. Something else did that. It was Commander Reed Wiseman's voice, calm at first, then colored with something that does not usually enter astronaut communications: pure, unfiltered amazement. He told Mission Control something that made the lunar science team freeze. He told them the crew was seeing impact flashes on the moon, live, in real time, right now as they flew overhead. Let that sink in for a moment. The Artemis II crew was watching the moon being hit by space rocks and seeing the explosions with their naked eyes. Here is why that matters so much that it made trained scientists audibly scream with delight in Mission Control. When a meteoroid, even a small one, slams into the lunar surface, it is traveling at tens of kilometers per second. That kind of kinetic energy, upon impact with solid rock in a vacuum, converts almost instantaneously into heat and light. The collision generates temperatures comparable to the surface of the sun. For a fraction of a second, a tiny point on the moon's surface burns as bright as a star. These flashes are called impact events, and they happen with a frequency that would alarm most people if they stopped to think about it. The moon has no atmosphere. There is no barrier, no friction, no burn-up zone. Every piece of debris the solar system throws at the moon hits it, every single one. And because of that, the moon accumulates these impacts continuously, endlessly, over billions of years, which is why its surface looks the way it does. Ancient, cratered, battered into submission by cosmic time. But here's the thing. Capturing these impact flashes with technology is extraordinarily difficult. Cameras struggle with the timing, the sensitivity, the positioning. Ground-based telescopes have occasionally documented them, but the success rate is low, the data is partial, and the scientific value is limited. What you need, what scientists have always wanted but never had, is a human observer in proximity, trained to look with eyes that adapt to darkness, and a mind that can contextualize what it is seeing in real time. And the reason the crew of Artemis II could see these flashes at all was because of something else extraordinary that was happening at the same moment. After emerging from the communications blackout as Integrity rounded the far side of the moon and began its return trajectory, the moon slid directly between the spacecraft and the sun. A total solar eclipse, but not the kind you see from Earth, where the geometry is precise and the event lasts 3 minutes and the shadow races across a continent. This was different. This eclipse lasted 57 minutes, nearly an hour of totality. Because orbital mechanics at the moon's distance from the sun work differently, because the crew's trajectory placed them at exactly the right angle, they experienced something that no human being has ever experienced before in the history of our species. A total solar eclipse observed from behind the moon in deep space, lasting almost an hour. The sun's corona, its outer atmosphere, the layer of superheated plasma that extends millions of miles into space and is normally invisible against the blazing disk of the sun itself, became fully, spectacularly visible. The crew described it as baby hairs of light bleeding around the edges of the lunar disk. Think about what they were actually looking at: the corona of the sun, a structure so large it contains our entire inner solar system, being revealed by the silhouette of the moon in a moment of perfect cosmic alignment.